we've just come back from a month's research cruise. We've been to the Malin Shelf, which is just north of Ireland and just west of Scotland, and it's been part of a project called FASTNEt, which is to look at the exchange of water between the shallow seas and the very deep ocean. So the shallow shelf seas surround most of the land masses, say maybe 100 to 200 metres deep, and they're separated from a much deeper ocean, which is maybe 2,000, 3,000, 4,000 metres deep, by a narrow section where the seabed drops very, very rapidly. There's a very sharp drop, and we call that the shelf edge. So we're interested in how water crosses over that shelf edge, steep bathymetry area. And we're interested in that because of shelf seas being very, very productive regions. They only represent quite a small surface area percentage-wise of the global oceans, but they account for a much higher percentage of the productivity, so the biological growth that happens in the oceans. And they're also areas that, because of that growth, suck down lots of carbon dioxide from the atmosphere, and ultimately they're able to lock that away and move it in the bottom waters off to the much deeper ocean where it's locked away for a very long time. So we're interested in the physical mechanisms that allow water that has nutrients to sustain that growth to come onto the shelf, and the mechanisms that allow the carbon that's fixed to move off the shelf into the deeper water. So we've been to the Malin Shelf to look at a couple of these physical processes, and one of those is called the slope current. It's a large current running north-south that tracks that shelf edge, that steep area of seabed, all the way around the European shelf. So starting right off in France in the Bay of Biscay, coming up round Ireland, up the west coast of Scotland and overtopping Scotland. One of the things we were doing is putting instruments in the water to measure the strength of that current and the temperature and salinity of that current, and seeing how stable it is and how rigidly does it stick to that shelf edge and how often does it come onto the shelf. We put moorings down to do that, and we also did a dye release experiment. So we got some, it's called fluorescein, it's very fluorescent material, so it's bright green, you get it all over your hands and it turns out like your hands look like a sort of a visible jacket. Put a hose, we dropped a hose all the way down to 120 metres below the surface, and we pumped a lot of this fluorescein, this fluorescent liquid, into the water. Took the hose out, and for 3, maybe 4 days, we tracked where this patch of dye was. So we tried to put it right in the middle of this slope current. So we tracked how it was moving northwards within that slope current, and we were also monitoring how quickly it spread out in both directions to try and understand the behaviour of this current. So another component of why we were at the Malin Shelf was to put some instrumentation in the water that would stay out for a long time, so a year, to help us understand how over the seasons the structure and currents and the exchange in our shelf seas is changing. And one of the new pieces of technology we're using to do this are gliders. So they look a little bit like underwater torpedoes. They're yellow, about this long, and they run autonomously, so they're deployed over the side of the ship, and they're controlled from someone on land, and they're continually profiling up and down in the water column, measuring the temperature and the salinity in the water column, and we'll go and collect those in a year's time, so that will be continually crossing backwards and forwards across the shelf edge. As part of the FASTNEt project, we've been at sea for 26 days, and there's been about 30 scientists on board, about 25 crew on board, and we've been working round the clock to make sure our experiments are running, everything's working, and we interact very closely, the scientists interact very closely with all the ship's crew. For example, during the dye release experiment, we were monitoring where the dye was going, and we were talking regularly and very closely with personnel on the bridge to say, we think the position of the dye's changed, can we move the ship, can we have a new heading? So there's close collaboration between both scientists and ship's crew. Going to sea is certainly one of the rewarding parts of being an oceanographer, and I feel when you go to sea and you collect your own data, you appreciate it so much more, and you understand the value of it, and it helps you analyse it ultimately if you've understood how it's been collected. This is where we started our cruise in Glasgow on the James Cook, and we came out to this area here which is called the Malin Shelf. So this is west of Scotland, this is Northern Ireland, and these are the areas that we did our 2 dye release experiments in. So if I zoom in, this was our first dye release. So we started here and we pumped the dye in at about 120 metres, and it moved very slowly, say 20 centimetres a second, north-northeast along this shelf edge. This is the very steep drop between the shallow shelf seas and the much deeper open ocean. And as we were going along, if I zoom in a little more, these are the ship's tracks, and as we were moving along, when we saw dye in our profiles, we were marking green crosses, and when we weren't finding any more dye, we were marking red crosses, and together with some of the instrumentation on board, it was helping to guide the ship to continually follow this dye northwards. As it came across here, across one little canyon, and then across another little canyon as well.